the layouts, for extracting the text, for understanding the text, a lot of things again. Okay. So that is my work. Apart from my regular work, which I work on, it's a full-time job basically. Apart from my full-time job, I also do teachings. Basically, I'm interested in sharing my knowledge, and whatever I do in my regular company, I always share with people. So, and luckily, my first company was an edtech company. So from there itself, I got habituated to teaching, and I've not left teaching. So from last 7 years, also, last 7 years, I'm during weekends or during whenever I'm free from my regular work, I do teach people, and I'm also doing data mines from last 2 years, and we were training in multiple technologies of AI. Okay, that's a simple introduction about myself. Now let's understand. Okay, today what we'll be discussing, and we'll focus on what all things will be we'll be further discussing. Okay, so I already understood that you guys have completed your machine learning part, correct? Am I right? Am I right in that? I hope you guys have completed the machine learning part, right? That's great. That's great. Perfect. So now let's understand. Now, as you already know, the next upcoming sections, I mean the further things, whatever we are discussing, is all about deep learning and generative AI. Of course, the main focus is on generative AI. Of course, to learn generative AI, you should of course focus on some bit of deep learning part, right? So the next session will be focusing on that part basically. Okay. So first, I will explain you what all things you have learned. I mean, what all things you have learned till now, and what all things you will be further, exploring in this as a part of this particular course, and what all things you can expect from this, such that you can get an idea of what all things you'll be learning. Okay. First thing. Okay. Just give me a second. Yeah. Perfect. So as you guys have already completed the ML part, the machine learning part. So what you have learned in machine learning? First thing, what you have learned in machine learning? Anyone? What exactly you have done in machine learning? Anyone? Any one of you? Whatever you have learned, whatever you have understood, you can just put. Yeah. Okay. Predictions. Great. Predictions means given a input, based on the input, you are trying to build a model, right? You're trying to build a model which can give you the predictions. That's correct. That's correct. Okay. Anyone else? What you have learned in machine learning? One answer is predictions. Obviously, whenever you give an input, you have already built we call it as a machine learning model, and that model will be giving you the predictions. Fine. That's exactly correct. What's next? What all things, other things you have learned? Training the machine with existing data and predicting the future outcomes. Exactly correct. Next, training models using historical data. Of course, yes. Okay. And when you come to the models, when you specifically talk about machine learning, and when you come to the models, okay, this models part of machine learning, if I say models part of machine learning, what all models you have explored in machine learning? What all algorithms, I can say? We can more clearly say it's algorithms. What all algorithms you have explored? Because you are trying to build a model using an algorithm, right? You will be having one algorithm, and you will be, basically trying to build the models using algorithms. Correct. So tell me, what all algorithms you have learned in ML, machine learning? Of course, very good. Regression and classification algorithms you have learned, right? You have learned about regression and classification algorithms. Very good. And also you might also learned about the clustering algorithms. That's also great. Okay. You also learned about the clustering. Right. Okay. Now, in regression and classification, if I talk specifically, what all things you have also learned? In regression and classification, what are the specific models you have learned? Maybe whatever, few models which you have explored. Okay. Maybe linear regression, correct? Maybe logistic, right? Logistic. Okay. Maybe you have explored about naive Bayes, right? Maybe you have explored about decision tree. Maybe you have explored about random forest, etc. So these are the models which you have learned in your as part of your machine learning. Am I correct? Am I right, everyone? Perfect. Now I want to ask you, what are these models based on? What are these algorithms based on? What are these algorithms based on? Means how exactly the backend of these algorithms work in general. I'm asking in general, what happens in the backend in general? What happens in the backend in general? Can I say some kind of mathematical operation happens? Exactly. Some kind of mathematical equation you'll be having. For every algorithm, you'll be having some kind of mathematical equation, some kind of mathematical operation, right? Some kind of mathematical operation, right? And that leads to you. I mean, that actually learns the model. That learns from the historical data, correct? What is exactly happening here? Whatever algorithm you're having, that algorithm, you're feeding a historical data, and that algorithm learns from the historical data, and how it will learn based on this mathematical operation or this mathematical equation. Am I right? Am I right? That's how the ML is learned. That is how the ML works. Am I correct? Correct? Yes or no? Perfect. Now the point here is, now after doing this, after people are implementing this, researchers observed something. That is, with a simple data set, if you're having a simple data set, maybe let's assume a data set, a tabular data set, let's assume a tabular data set with some rows and columns. Okay. The researchers observed that with a simpler data set, these kind of models are really working great. Okay. With simpler data set, these models are perfect. But what observed is, whenever the complexity of this data set increases, whenever the complexity of patterns increases, these ML models are failing, are failing, right? Whenever the complexity of the data set increases, these models are failing. Now you can ask me, okay, let's add more data. Let's add more data and make the model better. But I will show you one interesting graph. I'll show one interesting observation, something like this. Okay. Let's assume you're having a graph like this. This graph was, I'm not drawing this graph randomly. Okay. This particular graph was experimented with various data sets and various problem statements, and I am showing this particular graph to you. Okay. So what this graph will contain is, in x-axis, you'll be having the data size basically. Okay. Data size. X-axis will be having the data size. In the y-axis, we'll be having the performance. Okay. In the y-axis, let's have the performance. X-axis, let's have the data size. Okay. Now, let me ask you a question. Ideally, according to whatever you have learned, with more and more data, can we achieve good performance? Just ideally speaking. Again, I'm speaking ideally. Maybe there might be a lot of other cases which, proves my statement wrong. But let's assume ideally, will you agree that, do we have a belief that with increase in data size, my performance will increase? Yes or no? Yes or no? Yeah, of course, that is a general belief, right? Because more and more data, more and more patterns, more and more patterns, more and more information, and it will be, I mean, model will be having, the algorithm will be having more and more scope to learn. But what actually happened is researchers have done this experiment by increasing lots of data. And what observed is for the traditional ML models, whatever you're seeing right now, it might be linear regression, logistic, naive Bayes, decision tree, random forest, whatever model ML models you have learned. What is observed is with increase in the data size, up to some level, the performance was increasing. That's a good news. Okay, you can see up to some level, you can see, imagine this is your data size, you're increasing the data size. Up to some level, you can see the performance is increasing. Let's assume you're having only 10 rows here. Let's assume, okay, this was your performance. Let's assume you're having now 100 rows. Here you're having 1000 rows. So you can see up to some level, the performance is perfectly increasing. But after that, what is observed is after some level, it is observed that the performance is just stable like this. Hence, the performance is not increasing. You can see it is just stable. Even though I increase my data set to 10,000, 20,000, 1 lakh, 2 lakh, 3 lakh, 4 lakh, 5 lakh also, still my performance is stable, right? You can see this is the main observation by the researchers. Okay, that okay with up to some level it is working really great, but after that you can see this kind of nature you can clearly see. Now with this kind of models, we cannot achieve a human-like systems. We can achieve basic system, but if you take chat gpt is like a human-like system, right? It works like it will give you the answers like a human. It will understand like a human, it will think like a human. But these with this kind of graph, whatever you are seeing right now, you cannot achieve a human like performance, right? I mean, this imagine this is your peak performance. Okay, imagine this is your peak, this is your peak performance. Okay, now our expectation is what, with increase in data sets, the data size, with increase in data size, maybe I can increase my, I mean, I can get the peak performance. But that was proved wrong. I mean, that was not happening. That is where researchers thought about different concepts, and that is where the concept of neural network came into the picture. Okay, the concept of neural network came into the picture. Now, first thing, see, every one of you know that the important part in your human brain is neuron, right? Now, here through AI, what we are trying to do, we are trying to make a replica of a human brain, correct? We are trying to replicate the human behavior. So, researchers thought that, okay, why not replicate the neurons itself? Because we are able to think, we are able to think, we are able to make decisions, we are able to analyze because of the neurons in your brain, correct? Now, why not replicate that? So from there, the idea of, from that inspiration, the idea of neural network came into the picture. Here, neural stands for neurons, right? Neural stands for neurons. That is artificial neurons, more clearly. Okay, artificial neurons. When I say artificial neurons, it's like the neuron which is made through programming. Okay, neurons, more clearly, I'll write it as an artificial neuron. Here, neural stands for artificial neuron. Okay, and network. See, in your brain, can I say we'll be having many number of neurons, right? Like we will not have only one neuron in your brain, right? To process, to analyze, to make decisions, will you have millions of neurons in the brain, and they are connected to each other. Am I correct? In the same way, when you're trying to create artificial neurons also, you will try to create a network. You will try to create multiple neurons and connect between them, and you'll process that information. Network means connections. Connections. So if you typically see, if you typically see the difference, uh, let me show you. Like if you see our biological neuron, if I take any kind of our biological neuron, I guess if you have seen, you might already seen this biological neuron a number of times, right? If I just search for biological neuron, these kind of neurons you've already seen a number of times, right? These neurons in your biology when you're studying, right? Now, same neurons we are trying to replicate. Okay, we are trying to replicate the functionality of neuron. We are trying to replicate artificially. Okay, So that is where the concept of neural network came into the picture. And we know that we have, like multiple neurons in your human brain. If you actually observe the neural, you know, nervous system, if I search for, if you see, uh, uh, like nervous network, if I search for, okay, whatever it might be, you'll be having lots of, yeah, if you see this, if you clearly see this picture, you can clearly see that these particular neurons are the artificial neurons which are connected to each other, passing on the information. That is the reason whatever you're seeing through eyes, or whatever you're, uh, uh, hearing through ears, through your, whatever you're listening through your ears, or whatever you're tasting through your tongue, whatever you're, smelling through your nose, all these things, information is going as an information to your neurons. And that is the reason you're able to analyze the surroundings, right? And whatever I'm speaking, you're able to listen because of this nature of the human brain. Same thing, what we are trying to do here is whatever this kind of network we are having, we are trying to replicate, and it looks something like this, right? So if you just look at this, the this how natural neural system looks in your human brain, whereas this artificial neural network looks something like this. Now, why I'm talking about neural network? Because here we are talking about deep learning. We want to learn about deep learning, correct? So deep learning is something which builds model using neural network. It's a branch of AI, I can say, right? Deep learning, DL, is branch of AI, branch of AI, which builds models, okay, build models using neural networks, using the concept of neural networks, right? And the typical neural networks look something like this. Means this becomes your model right now. This is your model. This is how the model looks. And this model will be learning from your data. This model will be learning from your, from your whatever input you're giving. Like whatever you're done in machine learning, you can do the same thing here and achieve the things. Now you can ask me, then why we are going for deep learning? What is the reason? What is the achievement? What we have achieved with deep learning? That is the important thing you have to understand. Okay. What is the thing you have achieved using deep learning? We'll try to understand. Okay. So let me take the same graph here in the bottom. So you understood, right? See, in machine learning, what you're doing in machine learning, you're basically focusing on basic mathematical operations. So basically in machine learning, majority of the models focuses on statistical and probability based, right? Statistics and probability based models, completely mathematical operation. Now here also there will be mathematical operation, but in a more advanced and in a more higher values, like longer, like we'll be having more number of neurons and more number of models here. Okay, so if you see, that is the reason, what we have achieved using deep learning means. If you ask me what you have achieved using deep learning, see, in machine learning we observed this problem, right? With increase in data size, your this performance is not increasing actually. After some point of time, after this point of time, it is stable. It is not even increasing. But the advantage of neural network is, if I just take this neural network, if you just look at this, in this neural network, if you carefully observe, this circles you're seeing, right? Each circle is actually called as neuron, right? Like how do we have neurons in your brain? This each circle is a neuron here. This one, this one, this one, this one. Every circle is acting like a neuron. So here in a neural network, we can have n number of neurons. See, like in our human brain, like how do we have multiple number of neurons? Here we are having an option to choose the number of neurons. I can increase the number of neurons here. Okay, like for example, here 1, 2, 3, 4, 5, 6. I'm having 6 neurons in this network, right? If you see in this network, I'm having 6 neurons. In this network also, I'm having, in this layer, I'm having 6 neurons, and here I'm having 6 neurons. I can make it 10, I can make it 20, I can make it 30, I can make it 100. So I can increase the size of my model, right? Getting my point? With help of this nature, I can increase my size of the model. So what researchers have done is, they have done a small experiment. Okay. First, they have chosen a smaller neural network. Okay. They went with a smaller neural network, With smaller neural network means what? With less number of neurons, you can assume. Okay, because this each circle is called as neurons, right? I told you that each circle is basically called as a neuron, correct? So let's assume they went with small number of neurons. Okay, small number of neurons. Okay, so then what happened here is what they have observed is, what researchers observed is, with smaller neural network. Observe carefully, everyone. Look at this graph. It will be very interesting. Let me take this color and show you, or let me take this one. Okay, fine. What they observed is, look at this. So it is okay. I mean, it is up to some level, it is behaving like the machine learning models only, you can see. But the good thing here is, with increasing data, the performance is actually increasing. It's not like stable. It's increasing like this. So you can see this is again with a smaller neural network only. Smaller neural network. So smaller neural network means what? With some number of neurons. Here you can see, if you see these circles, I told you it's a neuron, right? This circle, this circle is a neuron. I told you about this, correct? So the number of neurons you can choose in the when you are configuring the model. So with smaller network, a smaller number of neurons, you can see this is the achievement they achieved. Like at least it was better than the machine learning. You can see it is better than for the same data. Let's assume same data with same data size. You can see it is better than the machine learning model. Now what they have done here is they have increased the network size. Means they added more neurons. They added more number of these kind of layers. And now what they achieved is, let's assume the moderate level network. The moderate level network. Let's assume. Okay, let's assume this is your moderate network. Okay, so now you can see with increase in the network size, you can see this is moderate neural network. So with increase in network size, you can see they achieved a better performance than the smaller network. And then they went with larger network. With larger network, with with more number of neurons, with more number of layers. And then what they observed is, you can clearly see, that's an interesting point, that is, they observed this. Okay, so you can see with very large number of data, with very huge data, and with a larger neural network, okay, a larger neural network, you can see you're achieving the peak performance. And that is what you can see the ChatGPT. If you see ChatGPT is a very large model. That is the reason we call it as a large language model. It's a very large model, and it was trained with a very massive amount of data, right? So that is the reason it achieved this human-like peak performance. That is what was proved with deep learning. See, in machine learning, whatever problem we were seeing, let me label this as machine learning first. ML models. So whatever problem we have achieved with ML models, with complex patterns and complex data, these kind of deep learning models are solving. You can see, if you're having good resources to work with large number of data, large neural network indicates large number of layers, because data is in one dimension and layers is in one dimension. So large neural network indicates more number of layers and more number of neurons. Okay, again data set is separate. Here if you look at this white graph, Saiti, in this, if you see, I went with only 10 observations of data with large network. So if you see, the x-axis is indicating the data size. So with 10 observations, how much performance you're achieving with large neural network. With 100, how much you're achieving. 1000, how much you're achieving. So if you see x-axis, the data is changing. Okay, this indicates your more larger network. This white color indicates larger network. It can be one network, only one network, but larger network. But x-axis, you're increasing the data set. So the graph is moving exponentially like this. Got my point?
Yes, sir. Thank you.
Right? So if you see this peak performance, in this peak performance, if you see this part, here where you're having the large data and also the peak performance. Okay, and the large network. So both is there here. But if you take here, you're having a moderate data but it's a large network. like that. Okay, that's the difference. So from this graph, you can clearly see what neural network has proved us. What neural network has proved us. If you're having good resources to train a larger model, and if you're having a good data set, a very large data set, if you're having this both, then you can achieve the peak performance. And that is what ChatGPT also proved, right? Because ChatGPT, if you see ChatGPT, guys, ChatGPT was trained with, it is based out of a model called as uh, GPT 3. GPT 3. Okay, it is based on GPT 3. Now it is 4 also. 4.0, is also 4.0, 4.0, 4.0 is coming. But let's talk about GPT 3, which was, because why I'm talking about GPT 3 specifically, because it has created revolution, right? That is the reason. Now, GPT 3, if you take, it is approximately 175 billion parameters. So what is parameters means? Parameters is nothing but the neurons value, you can assume. Okay. Later on, we'll talk more about parameters. Let's not worry and go deep dive into that. But your ChatGPT is 175 billion parameters. Okay. ChatGPT is 175 billion parameters. So this billion indicates that many number of neurons you're having in your data, means in your model. So in your model, that many number of neurons you're having in your model, in your algorithm. So that is the reason why you can see that peak performance. And it was trained with large amount of data, right? It was trained with large amount of data. So that is where the concept of, this neural network proved it. Okay. Now, why we are talking about neural network? Because deep learning is a branch of AI which builds model using neural network. Okay. That is the reason, as we are focusing on generative AI and we are focusing on deep learning, that is the reason we are discussing about neural network. Okay. So any questions in this part? Clear up to now? Clear up to now, everyone? Any questions up to here? Any questions in this part? Everyone are clear till now? Okay. Okay. So now we learned about what is deep learning, right? Deep learning. Now let's talk about generative AI. And we'll understand the difference. What is the difference between deep learning and generative AI? And the good news is, generative AI is actually a branch of deep learning only, again, a sub branch of deep learning and sub branch of AI itself. Okay. That's the point. Okay. So let's talk about generative AI. Okay. See, now we already learned that deep learning is a branch which focuses on neural network, which builds model to build to do neural network. Okay. Now, what is the goal of deep learning algorithm? If I actually see the main goal of deep learning algorithm, if you see this picture, you'll understand clearly what is the main goal of deep learning algorithm. In deep learning algorithm, what happens is you will be having a historical data. Okay. You'll be having a historical data. You will make your model learn, and this time the model is neural network. In a traditional machine learning, see, you have learned about machine learning already, right? You have also learned about machine learning, right? If you see the traditional machine learning model, what happens in machine learning? You will be having one mathematical algorithm. This everyone actually answered this point that okay, you will be having a historical data. You will learn from the historical data, right? You'll be learning from the historical data, and then what happens is you will basically try to build the mathematical algorithm on top of the historical data. And basically you will be doing what ultimately the task is, what in machine learning you will be doing the predictions, right? Means given a input, you will be predicting something. That is what machine learning is. In deep learning also you'll be doing the same thing, right? If I just go to deep learning also, you will be doing the same thing. You'll be having a historical data. You will be, the model will be learning. The neural network will be learning from the historical data, and that gives you deep learning model, and that will also do predictions. So both machine learning and deep learning, the end goal is same, but the model changes. Instead of using a mathematical simple model, you are using a larger neural network model. Okay. Now, what is generative AI? What is generative AI? Generative AI is slightly different from the traditional models. Generative AI is all about generating content, as the name says, generative AI, right? Generative AI. It's a branch of AI which is responsible to generate content. Okay, which is designed to generate content. Okay, it's a branch of AI. It's a branch of AI which is designed, which is designed to generate content. Now, when I say generate content, what is meant by generating content? Okay. Again, your content can be anything. It can be a text. Okay. If you see ChatGPT, what it is doing, given a question, it is answering right in text format. It can answer. So it can generate a text, right? It can generate a text. Maybe it can generate an image also, obviously. If you see, many of the models can generate image. For example, if you see in ChatGPT, in GPT-4o, there are a lot of internal models which can generate image. For example, DALI, if you take DALI, can generate image, and also table diffusion, it can generate image, right? So it can generate text, generate image, generate audio, right? Generate video, whatever it might be. Ultimately, the thing is, your generative AI is a branch of AI which is designed to generate content. Means intelligently it will generate content. Like how we humans, see, now we speak something. I'm writing something on the screen. So I'm generating content ideally. But it's my natural, I mean, I'm generating the content. Means I'm writing something, means I'm generating the content. Now, same thing, if I do with my machine. Okay, if I am generating the content with a machine, it is generative AI. Okay, that branch is called as generative AI. So if you see this architecture, you can see here you'll be having some models. Again, same thing. You'll be having a historical data. You'll be making your model learn from the historical data, and ultimately you'll be getting a Gen AI model. We call it as a Gen AI model. And what it is doing, ultimately, the task is to generate content. Now, here, if you talk about models here specifically in generative AI, here we are using something called as transformers, and we are calling it as GANs, right? GAN. So transformer is what? See, again, the good news is transformer is again a deep learning model itself. Okay. So if you see, that is the reason why we say generative AI is a branch of deep learning again. Okay. It's a branch of AI subfield of deep learning. Okay. We can say it is a subfield of deep learning. So why it is called a subfield of deep learning? Because whatever generative AI models you're building most of the models, if you see in real time, like if you see this GPT, GPT or Gemini or Llama or whatever, they are based out of one specific architecture called as transformer architecture. Okay, transformer architecture. And the transformer architecture looks something like this. Okay, so whatever you're seeing this one, I mean, it is very small to see that. But if I just, or else I'll just show up separately in the research paper. That is, again, not to worry. But there is an architecture called as a transformer architecture. And this transformer architecture is, again, a deep learning based only. So you'll be having, I mean, it is an advanced deep learning model. Like, it's not a basic, just a simple neural network. It is an advanced deep learning model. See, if you carefully observe the differences, see, machine learning was very basic, right? ML was very basic. Now we made some advancements and we introduced something called as deep learning, right? We have added more neurons. We have increased the layers. We have added more, we have increased the architecture size, and we have achieved good performance. Now, again, we are going more deeper, more and more deeper, and we are calling it as generative AI, and we are building transformer models. And these transformer models are advanced deep learning only. Now, the good news is, see, all these are interrelated, guys. All these are interrelated. Why I'm saying? Because now, if you talk about deep learning, each neuron, whatever you see, right, we are calling it as neurons, right? Inside this, we are saying it is neurons. Inside the neuron, again, it will be a mathematical operation only. So whatever you see in machine learning, same thing happens here. So if you know machine learning, deep learning is very easy for you. Okay, if you know deep learning, generative AI is of course easy for you. So if you see this particular neurons, in these neurons, you'll be whatever mathematical operations happens inside this neuron is again whatever happens in machine learning. Okay, right. So let's see that. Yeah, so that is the idea. So transformer is the main thing. Transformer is the architecture which we generally use in order to, ultimately build the generative AI models. Okay, that is the reason if you see GPT stands for generative What GPT stands for? In chat GPT, GPT stands for what? Generative, pre-trained, retrained, transformer. Transformer. The word transformer here in the GPT, the word transformer is from the transformer architecture. Means it was built with transformer architecture. The same way other models, other famous models, whatever you are seeing, the generative AI models are based out of transformer architecture itself. Okay. Perfect. So any questions as of now? So if you see the difference between a traditional AI, I mean, this is the difference between machine learning and deep learning, fine. But if you see the difference between a generative AI and the regular machine learning and deep learning is, in deep learning or machine learning, what you're doing the prediction as the task as your prediction. Task will be your prediction. But in generative AI, the task is generating content, right? In generative AI, the task is generating content. Okay, that is the main difference here. Perfect. So, any questions? Any questions in this part? Got the overview? What is generative AI? What is basic deep learning? What is machine learning? Any questions? Perfect. Chalo. Now, because now generative AI is trending. That is the reason we are learning about generative AI, right? So let's talk more about generative AI. So what we actually have in generative AI, and I'll also tell you what all things you should be knowing in order to understand generative AI. Okay, chalo. So basically, guys, let's go deep dive into the generative AI right now, because that is a trending topic right now. So if you want to learn about generative AI, if you want to understand generative AI, and if you want to, work on generative AI, the major important thing you have to learn is called as LLMs. A very, very important thing you have to understand is LLMs. What is LLM? LLM basically stands for large language models. Okay. LLM stands for large language models. What is large language model? See, I told you already. Your large indicates huge network. Huge network. Okay, fine. Now, what is language model? What is language model? That is very important to understand. See, now, before talking about language models, most of the generative AI applications is based out of a separate branch, a specific branch called as NLP. Okay. Your NLP stands for natural language processing. Right. Now, what is natural language in general? What is natural language? As the name says, natural language. What is natural language in general? Natural language in general, according to you. What is natural language in general? Natural language. Yes, commonly spoken, human spoken, right? We can say human spoken, right? Human spoken. Whatever it can be, whatever language it can be. It can be English, Telugu, Tamil, Malayalam, whatever. But ultimately, human spoken language is called as natural language. Now, what is NLP is, it's a branch of AI again. NLP is a branch of AI. NLP is a branch of AI. Again, this NLP can be implemented by using deep learning models or machine learning models. Again, that is a very important point you have to understand. Okay. Now, NLP is a branch of AI which mainly deals with human spoken language. Okay, processing human spoken language. It's a branch of AI which mainly focuses on processing human spoken language, understanding human spoken language, on human spoken language. For example, you see Chat GPT is a perfect example. It's an NLP based app where what you do there, you just go and ask a question and get your answer. So it's understanding your question and answering you something, right? So it's an NLP based application. Or for example, if you see your in Gmail, when you type when you start typing a mail, Are you getting the next words predicted? Are you seeing that, okay, the moment you start typing something, it will suggest you the next words, correct? It starts suggesting you the next words. Have you ever used it? Right? That is again NLP based application where it will understand what you're typing and it will suggest you the next words. Okay, for example, you write like this, right? It comes under a very interesting project called as, very interesting concept called as next word prediction, where you or next sentence prediction. So what you do, you'll just say how and are, and you'll say dash. That's it. It will try to predict, okay, what you are saying here. Maybe you might say you. So it will start suggest you'll use that, right? Or the moment you get an email, it will try to it will try to suggest some replies also. That is again an NLP based application. So it's a AI which focuses on understanding human spoken text or human spoken language and try to help you. Okay, Gmail auto suggestion, exactly. And also when you're working with NLP guys, mainly you'll be working with text kind of data. Text data means, what is meant by text data means the human spoken text or human written text. Like for example, you go to Twitter and tweet something. That's a text data. Or you go to Facebook and write some comment, or you go to Instagram and write some comment. So those are all text data, human written text, or you'll write a review. That's a text data, right? Or it can be an audio data also. Audio also. Like, I'm just speaking right now. I can record my audio and, I can give it to AI to process it. Maybe I can give my audio to AI to convert into other language, right? So that's all about language model, right? Like natural language model. Now, if you see in this LLM, large indicates what? Very huge network. And language model is nothing but which understands language, which understand human spoken language, right? Human spoken language, right? So that is LLM. Most of the models you're seeing, these are LLMs only, okay? Now, apart from LLMs, you're also having VLMs. VLMs. LLM is one part. What is LLM? Large language models. They are large enough. Now the question is why they are large enough? Because will you all agree that human spoken language is very difficult to understand? Our human grammar, if you take either you take English or you take Tamil or you take Telugu or you take Malayalam, any language you take, it is complex to understand. Do you agree? Do you guys agree? Do you guys agree that it is very complex to understand the human spoken language? Right? That is first thing. That is first thing. And second thing is, okay, maybe it understands, but giving you the reply in the same way, applying some intelligence on top of that, and giving you the reply needs a very large model. Basic simple model might not work. That is the reason these kind of models are very, very large enough. They are very, very large enough. That is the reason they are called as large language models. Okay. In the same way, like how do we have large language models? We are also having something called as VLM. That is called as vision language models. Vision language models. What is meant by vision language models? These are also large only. Of course, it's not like, okay, because there is no large here, that is the reason they are not large. No, even VLM is also large, but VLM is slightly different. What is VLM? Okay, vision means what? First thing, anyone? What is vision in general? What is vision in general? Okay, image. Acha. More specifically, vision. Can I say vision is nothing but ability to see? Vision is nothing but see, now we are having a again in again this comes again the great example of language complexity. In English, vision can be conveyed in two ways. One is the way we see, ability to see, like we are able to see, that is a vision. And they will say, okay, you should have a vision, a goal. Goal is also vision. Like again, two different meanings, right? Just now we spoke that language is always complex. We have an example again here now. Okay, fine. So now vision. Vision is what? Vision is ability to see, right? You are able to see through your eyes, right? Ability to see. In the same way, now I want my machine to see the surroundings, because we as a human, we are able to see the surroundings and understand what is happening in the surroundings. Now, same thing, I want to give a capability to machine to see surroundings and see what happens and understand from that. So what is the best option for the machine to see surroundings? How can a machine see? How can a machine see surroundings? Maybe through camera? Through camera, yes, through camera. And what camera captures? Obviously, images and videos, correct? So there is one more branch now I've talked about, that is computer vision. Now we talked about NLP, right? And that is where we talked about large language models. Now VLMs they comes under computer vision. Computer vision. So what is computer vision? Means same thing. Computer understanding the vision, doing the vision, understanding something from the image, analyzing the image. For example, I'll just open one random image. Okay. I'll just open one random image. For example, this one. What is this one? What is this image? What is this? What is this? Everyone can say it's a CCTV camera, correct? Everyone says it is a CCTV camera. How do you know? Because you have already seen it. In the same way, I want my machine to understand that, right? So computer vision is a branch of AI which focuses on processing images and videos. Okay. It's a branch of AI which focuses on images and videos. Images and videos. Okay. And again, vision models can be built using machine learning, deep learning, or generative AI. But if you are using images or videos as a data, then it is called as computer vision. See, depending upon the data, they have given the branches, guys. See, but ultimately, these three are the main branches. What are those? ML, DL, and generative AI. These three are the main branches. Now, in the data, because you're having historical data here. In the historical data, if you're using an image, maybe we can call it as a vision models. And if you are using a text data, maybe we can call it as a language models. If you're using a tabular data, we can call it as a deep learning or machine learning model. There is no specific name for the tabular data specifically. Okay, fine. So now this is vision models. Now, what is vision language models? See, here we're talking about vision language models. See, now the good thing about VLMs is it is combining the language and vision. See, now you will just see through your eyes. Now, if I ask you what you are seeing here, I'll just open one random image for you. Okay. I'll open one random image for you. Okay. One interesting image maybe for you guys and ask you, what do you see in this? What do you see here? What is this? What is this? What is this? Explain this. What you are seeing, explain this. If I ask you. If I ask you, explain this. iPhone and specifications. You'll say, okay, it's an iPhone which is having so and so camera, it's so and so, so and so, right? So now, if you see whatever you are seeing, you are able to explain with your language, correct? Are you getting my point? Whatever you're seeing, you just okay, whatever you're seeing, maybe you will be storing in your mind, but are you explaining with your language the way you present it with your language? So that is the reason this language and vision was combined, and they're calling it as VLMs, vision language models, where you will just maybe in vision language models, you can say, okay, I'll just give an image to the model and ask it to explain. So image to text or text to image. You'll give some text and ask it to generate an image, something like this. Okay. I'll show a small example. Wait, I'll show one example. Just now, I'll just show one example. I guess I don't need to show specific example of LLM because already you have done many LLMs in your, you have used ChatGPT a number of times, correct? You have used ChatGPT a number of times. So I don't need to specifically talk about LLMs, but I'll show the vision models. Okay. So I'll ask it to, okay, maybe I'll say, let me check if I'm logged in. Okay. I guess I'm not logged in. Let me check if it allows me to use the image model. Okay. So I'll simply say, generate a image of a person giving a speech. Okay. For example, now if you see, I'm asking it to instead of generate, I'll be using a simple terms. Okay. Okay. So if you see here, I'm asking in my own language. So here I'm asking it to in my own language and asking to do something. Now, what it is doing, it is trying to understand my language, and accordingly, it will try to, give me an image. I mean, that image might be wrong or correct. That is a different scenario. Okay. But ultimately here, I'm trying to generate something, generate content, and that too, I'm trying to generate an image. Okay. So that is where, you're talking about a vision model. Okay. So you can see a simple image has been generated where, I just asked it to generate an image of a person giving a speech, and it is trying to generate an image of a person, you know, something like this. Okay. This is how the VLM works, vision language models. In the same way, for example, imagine I'm having the image here. I'll just save this image. Okay. I'll just save one random image, or I'll just try to upload one random image from my system, and I'll ask it to explain what do you see in this. Okay. Let's see what my model says. Okay. So if I just open one random image, okay, I'll just give this image. Yeah, I'll just give this image. Okay. So I'll just say, I'll ask, oh, what do you see in this image, right? So it will try to maybe understand what it sees in this image and maybe it will give a reply. Okay, let's see. You can see it says this image appears to be a show or retail store counter with a plastic bins containing various medical or pain relief products. That's exactly correct. It's a pain relief product, while like Volin, right? Maybe yeah. And you can see a lot of it was able to identify that also. That's a good thing. And the bin are colored coded blue and red, contains boxes and bottles of topical pain relief products. Some of visible brands include Volini and Mignil. Okay. In the background shelves, you can see it was able to just from the image, it is able to explain what all it sees in the image. Like whatever vision we have, whatever capability we have, we are able to give that to AI, and we were able to achieve this, right? We are able to achieve this. It is able to explain this. This is nothing but called as VLM, Vision Language Models. Means it is able to explain whatever it is able to see in the language. Okay. So that is also one more part in when you're working with generative AI, mainly LLMs and VLMs. Okay. These are basic things. Again, there are a lot of things you have to learn, but these are the basic things. Now let's focus on LLMs. Okay. Okay. First, let's focus on LLMs. So what are LLMs? As I told you already, these are large language models. Large language models, right? Okay. They're responsible for what? They're responsible for generating the text. They're responsible for generating the text. Correct? Now, basically, apart from LLMs right now, from last 6 to 8 months, okay, a new concept with LLMs was introduced. That also you have to learn. That is agentic AI. Okay. It's an advancement of generative AI, we can say. That is agentic AI. Now, again, this is completely again based on LLMs only. Okay. What is agentic AI? Now, why the researchers or why the people have introduced the concept of agentic AI? Okay. Now, what LLM is doing? First thing, before talking about agentic AI, what is LLM doing? Tell me. What is LLM doing? What exactly is LLM doing? In general, according to whatever you have understood, what is LLMs doing? What are LLMs doing? What are LLMs or VLMs doing? Anyone? Generating the content, right? Generating text or generating image. Will you agree? generating text or generating image. That's it. That is the job of LLMs, right? Generating text or generating image, something like that. Ultimately, generating content. In general, we can say generating content. Okay, fine. Generating the content. Now the question is, does this LLM have the option or have the access to do or take decisions by its own? Or can LLMs do a generalized tasks for you? For example, can LLM book a cab for you? Can LLM maybe let me tell you examples, okay? Maybe invest in a stock market for you. Can LLMs invest in stock market for you? Okay. Can LLMs invest in stock market for you? Can LLMs maybe do some regular like simple task or regular task or automate regular task or automate tasks for you? So LLM is only responsible for generating content, but LLM is not having the access to some tools or some kind of things which can do some tasks for you. You can only generate content. You go to ChatGPT and do what? You generate content. That's it. You'll copy that and paste it in your system, or you go to the DALI and generate some image and copy and paste it, or you just go to some other LLM and just generate content, copy and paste it. That's it. But you're not doing some task with that, right? You're not integrating your regular work. You're right. You're not integrating in regular work. For example, imagine you're using VS Code for writing the code, or you're using the what we say Jupyter for writing the code. Now, if you want to generate, you'll go to LLM, ask it to generate this, and you'll copy and paste it. But we can also integrate directly to the LLM into your Jupyter, right? And ask it to generate there itself, do it there itself, according to the previous code, something like that. So that is where the concept of agentic AI came into the picture. Now, what is agentic AI means? Agentic AI is again a branch of AI, sub-branch of generative AI. And what is the use of the agentic AI is? Agentic AI is mainly focusing on automating things or performing the tasks. Okay. Performing specific tasks using tools. So what happens in agent is, using agentic AI, you can build something called as agents. And what is the job of agent is, every agent will be having a tasks. And this task, for doing this task, to this agent, you will give set of tools. You will give set of tools. You will give LLM, access of LLM, and also you'll give the context and the goal. And what is the job of this agent is to use this LLM as an intelligence and use these tools to perform this task. Like, for example, imagine you as a person, okay? You as a person, okay? Now you are having your brain, but with only brain, you cannot do anything, right? You should have your hands. You should have some tools. For example, now I'm having a brain. For example, I know what is AI. Now, if I want to build some AI-based systems, I should have some tools. Without tools, I cannot do anything. For example, imagine you're good in building UIs for websites. Okay, that knowledge you're having in brain, but with that knowledge, can you build the UI? With only that knowledge, can you build the UI? No, right? You need some tools to build the UI, correct? Without that tools, can you build the UI? Can you write the code without the tools? Can you deploy the code without the tools? Tell me. You're having your knowledge in your brain, but can you do things with that knowledge directly without the tools? Tell me, guys. Means without laptop, can you build a UI first thing? Yes, I'm just asking a simple. Without laptop, can you build? See, the knowledge is in your brain. But if you want to implement that knowledge in a physical world, if you want to implement that knowledge, you need some tools, you need some things. And that knowledge also should know how to use the tools. See, in our case also, just theoretical understanding is not required. Both theoretical and practical understanding is required, correct? Means why in companies also, why they say that you have to do projects, or they will look at your projects, because they'll see that how good are you in using tools, how good is your knowledge in using tools, how good is your knowledge in building things. In the same way, LLM is just a knowledge. LLM is just a knowledge. But using that knowledge, if you want to implement something, you need tools. Without tools, you cannot do that. That is what your agentic AI does. Agentic AI is something which is responsible to build tasks or perform tasks using AI. Specific task, it can be anything. And there you'll be building agent, and agent will be assigned a task with the knowledge. This will be acting like a knowledge, right? And these tools you'll be giving in order to use that knowledge and perform the task. Use that knowledge and perform the task. See, LLM is like a brain. LLM is just a brain. But that brain, if you want to implement something using that brain, you need agents. That is what the concept of agentic AI into the picture. So agentic AI is something which use these brains and use the tools provided and use the goal to perform the task. Now, this LLM should be specialized enough to use these tools. It is not only having the knowledge to just generate content. It is not only having the knowledge to generate image, but using that, whatever it can do, whatever generation things it can do, using that, it should use these tools and do specific tasks. That is what agents is all about. Agentic AI is all about, right? So, for example, I'll tell you some examples of agentic AI. How many of you heard about cursors? Cursor. Anyone heard about cursor? Very, very famous right now trending things in the AI field. Cursor, anyone? Actually, if you start using cursor, you will forget VS Code. Anyone heard about it, cursor? Not your system cursor, of course, but a tool called as cursor. A very, very famous tool. Okay, I'll tell you. So what cursor done, very interesting thing, guys. What cursor people, the team of cursor have done is, you have used VS Code, na? Everyone, anyone, I guess you guys have used VS Code. You have used VS Code? Yeah. I mean, generally, VS Code, what do you do VS Code? You'll write code, correct? Okay. And VS Code is by Microsoft. Everyone of you know, right? VS Code is Microsoft. And the good thing about VS Code is it is open source. It is open source. Means, what do I mean by open source? Is VS Code is a software where you can write code, right? For example, I'll just open my VS Code. For example, if I just open this VS Code, I'm just opening my VS Code, Visual Studio Code. Okay. Okay, so you can see this is a IDE. It's like an IDE. We call it as integrated development environment, where I can write some code here, right? I can start writing some code. Now, the point here is this VS Code is open source. Means anyone can see the code of the software. Anyone can modify it also. So what Cursor team has done this, they have taken the VS Code and they have attached an agent to it. They have built an agent where they have integrated the AI to this VS Code using the agent. And what it does is, and they release a new software called as Cursor. Cursor is a software. And what this Cursor does is, the moment you start writing the code, it will give you suggestions. It will generate the code there itself. It will generate documentation for your code, whatnot, multiple things. Okay. So Cursor is like an AI-based IDE now. It's an AI-based IDE. And the good thing about Cursor is, it's not a new IDE. It's again VS Code only, because VS Code is the most used IDE among developers. Now, developers no need to learn new things, or developers will not feel new. They are in a new environment. They are in their old environment only, but with AI-based agent. So how good is that, right? That is the reason Cursor became so famous, and it also received billions of funding. If you actually see in the internet, it is rocking actually, if you have already observed. So let me show you how it looks. Okay. Yeah, the AI code editor. So this is again from VS Code only. If you see the way it looks is again VS Code only, because it was built from VS Code only. You can directly download here and use it. Okay. This is one of the AI, means you can see how it works. You can see this. it starts, the moment it starts generating the content, no, you don't need to go to the LLM and do this. Okay. So it's kind of an agentic AI only, because you're using this to generate content, or generate code in your specific, you have designed it such a way that it can generate content in your system. Okay. Here you can see one example. You see what it is doing. Parallelize this because the API is slow. Okay. Just you write the content. The AI will automatically do this for you. Can you see this? Look at this. It is automatically doing it for you. Right? Correct. That's how, the next upcoming things work. Okay. So that is the idea. So like that, this is one example. Person is one example. Like that, we're having lots of cases where the agents are working right now. Agentic AI is very famous. Okay. So if you it's the next big thing I can say, the agentic AI. I'll show some examples of agentic AI and the tools used for building agentic AI. There are a lot of tools. Like there are tools like Crew AI. Crew AI is one thing which you can use for building AI agents. PyData is one thing which you can use for building AI agent, etc. Okay. So let me show examples here. You'll get an idea. Okay. I'll just open the Crew AI tool and show you how the agentic AI looks to get an idea. Okay. So again, here, if you carefully observe, it is not a new thing again. It is again using LLMs. It is using the knowledge, whatever it is having already, and it is actually building things. Okay. So you can see it's a leading multi-agent platform, Crew AI. And also you can build, the good thing here is not only simple agents. Agent we already learned, but it can also build multi-agents. I'll talk about that. Multi-agent, I'll talk about that. But let me go to open source. And here, I'm just showing you some examples, how agents are built here. Some examples I'll show you. Okay. So if you see this, guys, look at the left side is the documentation of Crew AI. So you can see there is agents, right? Agents, which is, as I told you already, it is something which responsible to perform specific tasks. You can see in Crew AI agent, what is agent? Agent is something which performs specific tasks, make decisions. That's the important thing. Makes decisions. It's not only just performing the task. For doing the task, it will make the decisions based on the role and goal you're giving. Because if you see, you're giving a goal for that. Okay, you're saying, okay, this is your goal. You have to achieve this, right? You have to achieve this. So I'm just giving a goal. Okay, use tools to accomplish. Mainly use tools. It will use tools to accomplish that. Communicate. You can also build multiple agents and do apply communication. Maintain memory. Okay, so this is the responsibilities of agents. Okay, and delegate. Delegate means give tasks to other agents. That is a different thing. Don't worry about that. That's an advanced thing again. So you can see, and knowledge will be like LLMs. LLMs are the knowledge for that. Okay, so that is the idea. Okay, some examples I have to show you. Wait, you can see there are a lot of tools here. You can see, if you see a lot of tools for LLMs to do the tasks. For example, code interpreter to understand the code. It's a tool to understand the code. Maybe like Brave search to search in the internet and do something for you. Okay, AI mind tool, or code docs rag search for searching some code. Lot of things you're having. And DALI tool to generate image. DALI again a tool for generating image. GitHub search for generating some for searching for some code. You can see there are a lot of tools here for you to do something. YouTube channel search. A lot of tools. Okay. I guess I want to see some. Yeah, here we're having examples. Yeah. So look at the examples, guys. Some good examples of agents you can see here. So first you can see marketing strategy. Automate marketing strategy creation. Okay. Automate marketing strategy. For example, you're having some marketing you should do, and you want to use AI for that. You can build an agent who can actually do this marketing for you. Okay. Or apply the marketing for you. Surprise trip. Okay. Or match profile to positions. LinkedIn. Create job posting. Game generator. Find jobs. For some examples. For example, I'll just go to market strategy agent. Let's see what happens. So you can see now, agent is doing what? Agent is actually based on the, okay, it is right to go into the code. Yeah, so based on the specific tools, it is doing the job. Okay. So I'll show some more examples of agents. Right. I'll just open PyData. PyData is also one more tool to actually build agent. So let me open the PyData. Here you can see some examples of agents. Let's show you. Let me show you. Yeah, you can see some examples. Yeah, you can see web search agent, an agent that can search
the web for you and give you the relevant information. Recipe creator agent, finance agent, an agent that can analyze financial data and give it to you. Okay, so if you just open finance agent, like for example, I'm just opening finance agent, you can see how you're creating a finance agent. First, you're creating an agent name. You're giving the model. Model is LLM. You're feeding the LLM to the model. Means you're giving LLM. Like you're saying, okay, this is your model. This is the knowledge you have to use. And you're giving some tools. You can see you're giving Y financial tools. YT finance tools is nothing but your it's a tool to get the financial information of a company or financial information of the stocks, listed stock companies, and all those things. So because it's a financial agent, you're giving a financial tool and you're asking it to do something, right? So you're giving a tool to do the task. What is the task? Doing some financing job, right? So whatever finance analysts do, you're asking it, the AI to do that by giving a tool, right? Books recommendation agent, shopping agent, okay, shopping agent, and you're giving some fire crawl tool. Maybe it is like crawling through the websites and give you this one. You can see you are a product recommender agent specialized in finding products that match user preferences. You can see you're giving some goal to the this one, and this is your model Gemini. It's using Gemini. Search for products, something like that. It's a books recommendation agent, shopping agent, weekend planner agent, agent team, Python agent. Python agent will see. Okay, it's kind of generating content using Python. I mean, generating code. Data analyst agent, which actually analyzes the data. Like that, you can see there are a lot of agents: research agent, image text agent, RAG agent, GitHub agent, like that. So like that, if you see, agentic AI is trending right now, where you're focusing on building agents, and agents is all about, you understood, right? It is using the LLMs, it is using the knowledge of LLMs to do the specific tasks for what? For achieving a goal. Okay, for achieving a goal. Okay, and the good thing here is the agent can make decisions by itself. Okay, but in LLM, you just give a question, it will give the answer. That's it. It will not make any decisions for it. But to do the task, agents will make decisions. Okay. So further you'll understand. Once if you proceed further, you'll understand what is how it will make decisions and all those things. But yeah, that is the next big thing. The agentic AI is the next big thing in the current market. Okay. So that is these are the few things you should understand. And yeah, the good thing here is you're in the agentic AI, you're not building only one agent. I mean, you can build only one agent, but to do complex tasks, you can also build multiple agents and they can communicate with them. For example, you want to build a website. Imagine you want to build a website for a company. Now, what happens? For a website, you want to hire a UI developer. You want to have one UI developer, one backend developer, and one database administrator who manages the databases, and one DevOps engineer who can deploy the API or deploy your web application. Correct? These all people you need. But now what you can do is you can create a crew of agents. That is the reason it is called as Crew AI, one of the framework, right? From there only they derive Crew AI. Okay, so you can create a crew of agents. Like for one agent you can have one agent. You can assign the goal of UI developer. It will generate the UI for you. You can have one more agent who can actually generate a backend code for that. You can have one more agent who works on database. So you have to give the access to that. Okay. And you can have one more agent who focuses on DevOps. And the good thing here is all this, and you can also have one more agent, which is manager agent, who manages all these agents. You can have one more agent. Okay. You can have one more agent, which is a manager agent, who can delegate the tasks to it, who can give the task to it. Manager agent. Okay. So now what happens? This manager agent will communicate with UI developer, with backend developer, with database engineer, with a DevOps team, and finally the manager agent will perform the task. I mean, will give you the task for you. Like that, you can build an agent and communicate with them. This is called as multi-agent AI, and that is how things are going on right now. Multiple agent AI.
These are the next big things coming up. Okay. So if you see in this Crew AI, I'll show some examples also. Okay, of multi-agent. Just a second. Somewhere here you're having multi-agent only. You can see agent team. You can see a team of agent and that can work together. Let's open this. So you can see there are two agents here. One is web agent who is responsible to search for websites, and second one is finance agent who is responsible to search and get the financial data. Now, these both are acting like a team who search in the financial tools and also websites and ultimately give you this one. So like that, okay. Two agents who's working to each other, working with each other, and web agent and their team actually right now, their team, they're working together and giving you, doing something for you, okay. So in the same way in Crew AI also, you can see lots of examples on multiple agent platform. You can see, I'll show you an example of Crew AI. Wait. Crews, if you see crew is nothing but that only. Crew means what? Group of team, right? Team of people. My crew, you will say, all right? So if you see the crews, you can actually give multiple agents. Let me show you. You can see this is how you can create an agent. Okay. There is no specific examples, but yeah, ideally, let me show you. Crew AI example. Someone, yeah, this person I've done it. You can see one tool is using is scrape website file writer. Yeah, you can see there is one agent who is doing something, and the task is this. Is a data analyst agent, but he has used only one agent. But basically, we can build multi-agent also. Okay, multi-agent systems. So that is what the agentic AI is all about. Okay, that is the next big thing you have to learn in the LLM after this one. Yeah, this is the official picture of Creo AI. You can just have a look into this also. Yeah, you can see guys, one example. So you can see what happens here is we'll be having multiple agents. One is content planner agent, one is content writer agent, and content editor agent. You can have three different agents like a crew. And these are responsible for what? You can see you'll be giving the tasks. For content planner agent, you'll be giving a content planner task. For content writer agent, you'll give giving the content writer task. And for the content editor agent, we'll give the content. So like, you can have three different agents working separately for you. So why separately? Because they can work better in better way. Like if you just, instead of giving only one task to entire agent at once or entire LLM at once, you're dividing the tasks among the agents, and you're giving to the agents, and it is working for you. That is how the agentic AI works. And it is again internally, if you look at the agentic AI, they're again internally using LLMs. If you see this model is nothing but LLM. You can see OpenAI GPT-4. It's an LLM model. It's a large language model. So LLM is like a model for them, like a knowledge for them. It is something which does, it's like a brain for it. Okay, which does all these things using the tools, using the content, using the extra knowledge, like that. Okay, this other things are like giving extra knowledge to do the task. Okay, so you're having the brain now, using the brain do something. That is agentic AI. Okay, so this is the basic idea of generative AI, like what all things will be having in generative AI. Any questions as of now? Anyone having any questions? Any doubts? Please ask. Are we clear till now? Any questions? Any doubts? Right. So we learned about what all things. We learned about what is deep learning, what is neural networks, why neural networks
why neural networks when compared with machine learning. Then generative AI. What is generative AI? How what happens in LLMs? What is LLMs? What is VLMs? And then we talked about agentic AI. Now let's slightly focus on the LLMs, slightly more. We'll just focus on LLMs, and then I'll give you the agenda of what all things will be learning in this entire part of the course. Okay, chalo. So if you talk about LLM specifically, okay, if I talk about LLMs, generally when you are working with generative AI and large language models, you guys have used many different types of LLMs in your regular work, right? You might use ChatGPT, maybe. With ChatGPT, everyone are using. You might use, some people might have used Claude. Claude is one more LLM model. You might use Grok by XAI. You might use Gemini by Google, like that, right? So these all are the closed sourced model. We call them as closed source model. So if I talk about LLMs, there are two types of LLMs according to the availability. Okay, one is open sourced and the closed source. Open sourced and the closed sourced LLMs. Now, closed sourced means what? Closed sourced means those are not the open architectures, or they are not available for the general users to access the model directly. You can only access through the APIs. So those are closed source models. Okay. Whereas open source models are the models where the architecture of that model is available directly for you. You can directly download it, directly modify, use it in your system and modify in your system. Okay. So there are two types of LLMs basically, closed sourced and open sourced. Okay. So here the architecture is open sourced. Open sourced. Here architecture is not open source. Not open source, as the name says. Right. Next one. Second one, here you can load the model directly, download the model directly. Download and use it. Download the model and use it. Right? You can directly download this model and use it. Use it in your local. But this one you can only access through API. Only access through API. Their API means you'll be having a link, you'll be having API and you can use it. Sometimes you have to pay for example, OpenAI. You have to pay for OpenAI, whereas Gemini is free, like that. Okay. Like this, these are the differences. Now the point is when to go for open source and when to go for closed sourced. When you're working with LLMs specifically, when you're working with LLMs, when to go for open source and closed source. Okay. See, whenever you're talking about LLMs, guys, very important thing you have to understand here is we have to talk about how large it is. That is very important. How large it is, how huge it is. Now, for example, if you talk about ChatGPT or this Gemini or Grok or Claude, these are very large models, almost billion, 100 billion, 1000, like 600 billion, 500 billion parameter model, right? 600 billion parameter per model. But now the question here is, if you're using an open source model, loading a 175 billion parameter model will be very huge. So whenever you're using open source models, you can slightly go with the smaller models. I'll tell you how much GPU you need for loading a large language model, okay, based on the parameters, because this will be helping you in open source. Okay. Now, for example, imagine you're working with on open source models.
some open source models. There are n number of open source models. If I talk about examples, let me write an example also here. The example of open source models are Llama by Facebook, by Meta, basically. If you have heard about it, there is something called as Gemma by Google, Pi 3 and Pi 2 and Pi 3 by Microsoft. We're having Mistral, DeepSeek. DeepSeek is also open source, etc. These are all open source models, open source LLMs. Okay. Whereas closed source LLMs are what? Your OpenAI API, OpenAI GPT. OpenAI GPT is closed sourced because you can only access that through API. You cannot download a chat GPT model or GPT model and use it in your system. Or Gemini, Google Gemini, like Claude, Grok. All these are closed source models. Means you cannot download these models in your local and use it. You can only use through the API and you have to pay for the API. Okay. Now, two things. If you are having enough resources to download and load this model in your local, directly you can go for open source models. But the problem is you should have enough resources and that is very costly. So in that case, you can go for a closed source LLMs. Like these kind of LLMs you can go for. Okay. And trust me, guys, training a LLM is very huge resource constraint. Big small players are not training LLMs. Small players like small companies, startups, they are not actually training LLMs. Only the big players, like the big players who are having enough budget, enough money, they are only training LLMs because training LLMs is a very huge cost, right? It requires a very huge budget, and the small players and mid-level companies cannot afford that cost. So most of the companies, what they do is either they use open source LLMs or closed source LLMs. Okay. So what happens in the differences in open source LLMs, there is no data privacy issues because the model is loaded in your local, the data will be in your local, right? No data privacy issues. No data privacy issues. No data privacy issues. Whereas in closed source LLMs, because the data is going outside, see now you're sending this data to the outside. Now, whenever you're calling an API, whatever data you're having to call the model, you're sending it outside. So you'll be having a data privacy issues. You'll be having a data privacy issues, right? So a lot of people will not recommend for closed source LLMs when you're having a confidential data, especially if you're having a bank data. Imagine you're having a bank transaction data of a customer. Now, sending the bank transaction data for a customer to any of these companies is not a recommended thing because if you're using the API of that particular company, like OpenAI API you're using, for example, or Gemini API you're using, even though they are not using your data, but we don't know what happens because it is completely once your data is outside your organization, we don't know what happens. Any kind of leak can happen. Okay. And no one is responsible for that, right? Ultimately, even if they are responsible also, once it is leaked, no one can do anything, right? Once it is leaked. So that is the reason a lot of people are concerned about data privacy issues. That is the reason a lot of companies who are having confidential data prefers local models, like open source models, loading locally. See, here I'm talking about just loading the model, using the model. I'm not talking about training the model because training the model, as I told you already, is very difficult for the small players. Okay. But we can do fine tuning. Fine tuning is possible. With a smaller GPU, we can do a fine tuning, but training needs a larger GPU. See, I'll just show you one simple example actually, and you'll understand how much costly is loading LLM only. Forget about training LLM. Loading LLM only, I'll tell you. Okay. See, I told you already that GPT-3 is 175 billion parameter model, correct? 175 billion parameter model. I told you already this, correct? In the same way, now loading 175 billion parameter is very huge in your local. But imagine you're using open source model, and imagine you want to load a 8 billion parameter model. Let's assume 8 billion, very small model, 8 billion. For loading a 8 billion parameter model, at least you need 8 GB of memory, 8 GB of GPU RAM, not CPU. You need a 8 GB of GPU RAM. And for loading a 13 billion parameter model, you need at least 12 GB. 12 GB of GPU RAM, right? And for loading a, maybe you can see maybe a 16 billion parameter model, at least you need 15 to 16 GB of 15 to 16 GB of GPU RAM. And what I'm saying, these all models are actually optimized models, not the raw models, not the direct models. So you can never load. It is for 8 billion only you need almost 24 GB of memory for raw models. But these are optimized models, optimized in terms of memory. So for just loading, not about training, forget about training. Training requires lots of memory. But just for loading the model and predicting or generating, not predicting, we can say generating content. For generating content, you need 8 GB of memory. Now, coming to the cost of these GPUs, if you want to buy a 12 GB GPU, 12 GB GPU, let's assume 12 GB GPU, with all the accessories, let's assume the motherboard, the RAM, the CPU RAM, the GPU RAM, GPU, of course, GPU will be having, hard disk, all this cost for 12 GB, at least if I take 12 GB minimum, okay, 12 GB RAM, 12 GB if you want to purchase, it's around approximately around, if I'm not wrong, it's around 1.5 lakhs. If I'm not wrong, yeah, 1.5 lakh, yeah, 1.5 to 1.6 approximately. Okay, I'm talking about the entire set, not only the GPU, not only GPU. Okay, and for 24 GB, it's around 2.9 lakhs. Okay, so like this, if you see, this is the budget, this is the cost of a GPU. This is only for loading the model and using it. Okay, and for inferencing, sorry, for training, you can just imagine how much memory. And if you see, these are very small models, 16 billion, 13 billion, 8 billion. So just imagine if you want to load 175 billion parameter model, how much of RAM you need and how much of budget you need, how much of, just for loading, forget about training, just for loading how much of, that is the reason, OpenAI itself is taking the funding from Microsoft to train the models, right? Because of this reason only. Okay. So that's you just loading an open source model. I mean, no problem. In our course, we'll be using Google Colab. Google Colab is will be giving you 15 GB of free GPU. You can use it for learning purpose. But I'm talking about in real time when you're using loading an open source model is costly. But the good thing here is no data privacy issues. You'll be having more control and all those things. But if you're using an API, and if your data is not confidential, let's assume if your data is not confidential, if your data is secure enough, I mean, if your data is not that important, you can go for APIs. And with these APIs, with a lesser cost itself, you can access a larger parameter model because you're using the API now. Obviously, you'll be having a lesser cost model. That is the idea of LLMs. Okay. Now, if you want to use open source models, there is one interesting framework called as Ollama. Okay. If I just open Ollama, okay, Ollama. In Ollama, it's a framework where you can host, which you can use to host your open source LLMs. Okay. So you can see these are the famous open source LLMs available, like Gemma 3. And if you see there is 1B, 4B, 12B, 27B, means different versions of the models. And also vision. It is also having vision, right? So you can see 1B means 1 billion, 2 billion, okay, 4 billion, 12 billion is 27 billion. Okay, some QWQ, Quen, okay. DeepSeek also is having open source. I guess you might already have about DeepSeek. And DeepSeek have multiple versions. You can see they have actually open source everything. They have also open source a very large parameter model. You can see 671 billion parameter model also they are open sourced it. But loading this is very difficult. So you're having 1.5 billion, 7 billion, 8 billion, 14 billion. Up to 14 billion, you can try up to 12 GB. Again, for 32 billion, you need at least 34 to 40 GB, 30 GB of GPU you need. 70 billion and 71 billion parameter model, like that. So like that, if you just go and see, there are a lot of models available, open source. You can see, these are all open source models only. Means you can directly download these models and use it in your local. But if you should have good GPU memory, or else you cannot do this. Okay, this is one framework for you. Other framework is LM Studio. Okay, LM Studio is one more framework where you can actually directly download this software. It's a UI based, simple, local AI toolkit. You can download this UI, this one, and you can just directly host the models, LM Studio. Or you're having Hugging Face. In Hugging Face, there are a lot of data sets and a lot of models available. Lot of data sets and a lot of models available, which you can use it. For example, DeepSeek, Quen, uh, uh, and all those things, even special means a lot of people will fine tune their models and host in Hugging Face. Okay, so you can use this ultimately as an open source LLMs. So yeah, so it depends upon the company, depends upon the choice, which one to use when. Okay, so this is the story of LLMs and how do you host LLMs and work with LLMs. Okay, so this is the basic idea of what all things you'll be having. I mean, what all things you have to understand. Any questions as of now? Any questions as of now? Are we clear? Are we clear, everyone? Remaining people, please confirm. Others. Okay. So now let's talk about what all things we'll be learning next. I mean, as a part of generative AI and deep learning. Okay. And then if you have any questions, we can, discuss. So as a part of generative and deep learning, guys, because as you know, deep learning and generative AI, deep learning is a generative AI is a branch of deep learning, and you should understand deep learning to get the generative AI. Okay. So the content, what all things will be covering is. So first we'll start with understanding neural networks, because obviously neural networks plays a very, very important role in your generative AI and also in deep learning, right? So for that reason, first we'll talk about, we'll discuss about ANN, okay? That is artificial neural networks, okay? We'll discuss how artificial neural network works. We'll be working on an example on that. Then we'll be working with image after this, image models. And for that, we'll be working with CNN, which is convolution neural networks, which is completely based out of image models. So here you'll be understanding how to work with images, and because convolution neural networks are designed for images, okay? And we'll be learning about RNN. So RNN is like a foundation for you for the generative AI, okay? Which is recurrent neural networks. Okay. So once these are done, these are basic foundations for you, these neural networks. Once these are done, we'll be starting the Gen AI. So as part of Gen AI, we'll be focusing on NLP, major on NLP, complete on NLP, because Gen AI is all about NLP and working with NLP based things, right? Language models. Just now we discussed, we already learned about large language models, right? So in NLP, we'll start with understanding what is word embeddings, right? What is word embeddings? Then we'll be implementing one use case of RNN on language model, like we'll be building one chatbot from scratch, okay, using RNN, right? Then we'll be exploring the transformer architecture. These word embeddings are very important, and then transformer architecture. Then we'll be focusing on LLMs, how to work with LLMs. In here, using for working with LLMs, guys, there are many important frameworks. In that, the very important framework is LangChain. So we'll explore about LangChain. We'll go deep dive into the LangChain, and we'll be understanding how LangChain works, how to integrate LLMs using LangChain, how to do all the integrations of various tools in LangChain. So all these things, how to build chains. This is very important framework for LLMs, for working with LLMs. We'll talk about prompt engineering, right? Because That is very important for generative AI. Prompting. Prompt is what? Prompt is nothing but the instruction, right? The instruction which you're giving to LLM. So how good your instruction, that good you'll be getting the result. So prompt engineering is very important thing because it will be playing a very, very major role to give you the get output. Now, if for example, if you just go back and see whatever we have just done, here we just asked about to generate, what do you see in this image? It's able to respond. And for generating an image, we can say, give me an image of a person giving a speech. So here I'm asking about, um, you know, I'm prompting it. I'm asking something, right? So the more good you prompt, more better is your output, especially when you're working with open source LLMs with small models. Okay. So prompt engineering is one thing we'll be focusing on. Here itself, we talk about a lot of approaches, sort of things. Here itself, we talk about RAG, very important approach, RAG. And then we'll talk about agentic AI. Then we'll go into the concept of agentic AI. We'll explore about Crew AI. Crew AI will understand how Crew AI works, how to build agents using Crew AI, how to build multi-agents and all those things. And then we'll also, if time permits, because this fine-tuning is very costly actually, but if time permits, I'll also show you how to fine-tune an LLM. Okay. So after this, we'll also do one project, obviously. And see, this is you'll be having one final project. Apart from that, in mid, you'll be doing a lot of projects here. I didn't wrote projects in this list, but you'll be doing even in year also. At every stage, you'll be doing some projects. Here also, you'll be doing some projects. And in the LLMs case, we'll explore both. We'll explore open source LLMs, and also we'll explore closed source LLMs. Okay. So this is the structure. This is the things which we'll be learning in this entire, part. Yeah. So I'm not writing every point again deeply. I'm just writing the overview of what all things you'll be learning, so that you'll also get the idea. Yeah. So any questions? This is the things we'll be learning. So anyone having any questions or doubts, you're open for that right now. Any questions? Any doubts? Any small question, don't hesitate to ask regarding anything.
Do we have tomorrow class, Akshay?
Are we clear? And also, when you're working with LLMs, we'll not only work on just the text-based LLMs, we'll also work with the vision-based also. Okay. We'll also explore about VLMs, like vision-based LLMs, vision-based models also. Okay. We'll be working with vision-based models. We'll explore how to work with image models also. Okay. Yeah. So any questions, any doubts? Open for that. Python. Python, and we'll be using this all the framework like LangChain is based on Python. In the Crew AI is also based on Python. Programming is Python. When you say platform, what do you specifically mean? The programming language or anything else? Like frameworks. Frameworks is nothing but language like LangChain, Crew AI. These are the frameworks we'll be using. So when you say platform,
what exactly you meant. The ID will be using both VS Code and also the Jupyter Notebook, obviously. Any specific thing you need? Specific thing on us? I mean, regarding.
No,
You can
just
let
I
me know.
wanted
I
to
mean,
check.
platform is a generalized word, but
Yeah.
talking about language or frameworks or the IDE, let me know. Actually, no. Will not be using the cursor IDE. We'll be using VS Code and Jupyter only. Cursor IDE is, of course, you can use in your regular work, not for learning. If you use cursor IDE for learning, then you'll get habituated to it and you'll be not able to do things by your own. Cursor ID, you can do it when you become the pro or when you actually, get the code or, you're able to write the code on your own. Or else you'll not be able to code by yourself. So there is both advantage and disadvantage. Next, any questions? Any other questions? Arun, I hope your question is cleared, right?
Yeah, it's clear. Thank you.
Wait, if you're speaking something, your voice is not clear. Can you try repeating? Just a second. Okay. 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 Anything else, anyone? Anyone having any questions? Are we clear till now? So I hope you got an understanding on what is deep learning, what is generative AI, what is LLMs, what is open source LLMs, what is closed source LLMs, agentic AI. Of course, the next big thing is agentic AI. Okay. So if you have any questions, you can ask right now, or if you are clear, we are actually done for the day. This is what a simple introduction we want to give for you. Yeah. Thank you for today.
Abhishek, when is the next class?
Sorry, 1 minute, Venkat. I guess you're not audible. I'll try to, turn off my. Can you try speaking now?
Yeah. Do we have tomorrow class or next week?
Tomorrow, I guess we don't have any class. Yeah, you'll get the information from the management regarding what is the next class. Okay.
Okay. Fine.
Thank you. Thank you. Thank you, Venkat. Thank you, Arun. Thank you. Cheers.